All right, in this video, I'd like to continue with some factoring, getting a little bit more complicated. So here we have an expression, 6x minus 4, and we're trying to pull out the greatest common factor that lives in both of these. So it looks like 2 is the greatest common factor because 2 goes into 6 three times and into 4 twice. So what we can do is we can extract the 2, and then if we pull the 2 out of here, we get a 3. And then if we pull a 2 out of here, we get another 2. So meaning this is the fully factored form. Okay? Because if you redistribute this 2 over everything in here, you get back to the original expression. Okay? So that's what it means to factor. And this entire thing is your answer. So don't just write 2. Don't just write 3x minus 2. Write 2 times the quantity 3x minus 2. And I didn't have to put a little multiplication dot in there because it's assumed, but if you want to put it in, feel free to do so. Okay, so let's make it a little bit more difficult. Let's say we had 6x minus 4x, okay? Now I realize that you can just combine these. 6x minus 4x is 2x. I realize you can do that. But I just for this demonstration, I want to be able to show that there is not only a 2 that lives in both of these terms, but also an x as well. So if I were to factor this, I mean, I understand that it can get back to 2x very easily. But let's say we weren't going to do that. We were just going to try to factor as is. We would pull out the 2. But we would also pull out an x. So now it would be just 3 here because 2x times 3 is 6x. And then here it would just be a 2 because 2x times 2 would give you 4x. Okay? And by the way, do you see that 3 minus 2 is 1? So that's 2x times 1, which is just 2x, which is exactly what you would have found out in the first place. But I just want to show that you can not only sometimes pull out a factor of the coefficient, but sometimes there's a factor of the variable as well. For instance, let's say that we had that, 6x minus 4x squared. Now this really is something that you cannot combine at the beginning like we could if they just had x's, because this has an x squared. It's a completely different term, absolutely different term. So we cannot just subtract these right away at all. But what we can do is we can find common factors in both. So again, 2 is a common factor in both of these. We can pull that out. And then what else is a common factor? Just an x, because there's an x that lives here and there's an x times x here, so we can pull out one of those x's, all right? So what that looks like is 3, oh, I'm sorry, this whole time I was saying we could pull out both a 2 and an x, so I should write that, 2x. Again, if you want to write a little multiplication dot there, feel free to, but you don't have to. So we can pull out the 2x from both of these terms, and that leaves us with 3, because 2x times 3 gives us back to 6x. Minus, okay, we pull the 2 out, okay, so 2 times 2 is 4, so I need a 2 here, and then I need my just 1x here. So this is a fully factored state. Because if I were to distribute this 2x over to 3, I'd get back to 6x, and then subtraction, and then 2x times 2x is 4x squared, meaning 2x times 2x. You could rearrange that by saying 2 times 2 times x. I'm pretty low on the video there, but as you see, this is 4, and that's x squared. Okay, so we're pulling out variables now. Okay, so let's move on even further. How about 12x cubed minus, let's say, 4x to the 5th. Okay, so we're going to pull out the greatest common factor. What's the greatest common factor of 12 and 4? 3. No, 4. Sorry. The greatest common factor of 12 and 4 is 4. All right, so we can pull a 4 out. Okay, so you know that there's going to be a parentheses. So if you want to kind of set this up as a template, put a parentheses down, okay? And then on the outside, you know that you're going to be putting some numbers and variables here. Sometimes just numbers, sometimes just variables, or a combination. Okay, so work with the coefficients first and then move to the variables. So the coefficient, the greatest common factor between 4 and 12 is 4. Great. Now let's move on. Oh, and so now, if you want, you can say, okay, I know there needs to be a 3 in here. Whatever operation is there needs to be here. Just put it here. And then 4 is just a product of 1 and 4. So I'll put a 1 here. Okay? So if I distribute this back, I'd get a 12 minus 4. Okay, now let's look at the x's. What is the greatest common factor of x cubed and x to the 5th? Well, if you want, you don't have to, but just an intermediary step, we have x times itself 3 times here, and we have x times itself 5 times here. So this is the exponent, and x is the base, okay? So we have x times x times x, and here we have x times x times x times x times x. So it looks like x times itself 3 times is the greatest common factor. So I could pull that out as x cubed, okay? So if I pull out the x cubed, what am I left with here? X squared. So here, there's an x squared left behind. 1 times x squared, okay? And over here, this entire x cubed got pulled out completely. So there's nothing gonna be multiplied by 3 in here. So it's 4x cubed times 3 minus 1 times x squared. Now a couple things. This, just to make it a little tidier, I could put the subtraction sign like that, nice and big. And then 1 as a coefficient is not wrong to have, it's just completely unnecessary. Because 1 times anything is just what that anything is. So this is totally fine. And if I want to move the x squared over just a little bit just to look nice, that's fine too. So this is the fully factored state of this original expression. 4x cubed times a quantity 3 minus x squared. Because if I distributed this back, 4 times 3 is 12, and then this x cubed goes with it. Subtracting 4 times x squared is 4x squared, and then x to the 3rd times x to the 2nd equals x to the 5th. Because what is this but nothing else other than x times x times x times x times x. That's x times itself 5 times, which is x to the 5th, okay? If you want to think about it, a shorthand is you just add these exponents. If you want to just add the exponents, that's a shorthand way of doing it. Okay, so this is how you would do that. All right, let's move on to if you have different kinds of variables. All right, well, let's say we had something like, I don't know, maybe 81 x to the 3rd y to the 2nd plus 27 x to the 2nd y. Let's say that's what we have. So we have a coefficient and then 2 types of variables. All right. By the way, we cannot combine these two because the x cubed and the x squared makes it different terms. So these are completely different terms. You can't add them together. Okay, and the y squared is different than the y. But what is, let's start out. Okay, we know that we're gonna have to have a parentheses, and we know we're gonna have to put some numbers and maybe even some variables out here. What's the greatest common factor between 81 and 27? 9, okay? Because 9 goes into 81 9 times, 9 goes into 27 3 times. So I'll put the 9 out here with some extra space because I know I might need to put in some variables. And then I know that I'm going to be 9 times 9, and then leaving some room here. So want to leave plenty of room for here. Okay, because 9 times 9 gets us back to 81. 9 times 3 gets us to 27. Okay, let's think of the greatest common factors. Let's just go by with the x's. X cubed and x squared. So this is, again, x times x times x, and then this is x times x. So what is the greatest common factor of these? X times x, okay? Because x times x gets completely used up here, x times x, and you're left with 1x here. So I can pull out the x squared. There's still one x here remaining behind, and I've used up all those x's, so I don't need that. Okay, actually, we're running out of room. Let me put this over here now. Okay, now let's go with our y's. What is the greatest common factor between y squared, which is y times y, and just y? Well, y. It has a y in common. So I could extract that y. Okay, there's a y still left over here. And then I don't need anything actually over here because I only had one y to begin with, so that's good. So actually I give myself a little bit more room than I even needed, which is fine. So this is our fully factored version of the expression above, okay? So 9x squared y. If you want, you can put little multiplication signs between each of them. You don't have to, but it's implied because it's implied. But do you see that 9x squared y is the greatest common factor that lives inside both this and this term? 9x squared is living in here, and x squared lives in here, and a y lives in here, and a y lives in there. Meaning, if I were to distribute this over to this, I would do 9 times 9 is 81, x squared times x is x cubed, y times y is y squared, plus whatever the operation is, you just bring it down. And then 9 times 3 is 27, and then this gets brought along with it, and there's nothing x or y to multiply, so we just keep that x squared y, and voila, this is the entire factored expression. Again, you have to write this down, and then a parentheses, and then what's left over inside. This whole thing is considered the factored expression. Just don't say, okay, well, I know that 9x squared y is the greatest common factor, so I'm just gonna write that down on the page. No. That's on the outside of the parentheses, and then you gotta write everything that was left over in the parentheses and then multiply it, all right? Multiply it all times each other, and that'll give you what you need. So let me give you a couple of those practices so you can do your own factoring with coefficients and different types of variables.